Welcome to Curious Kids Academy. Float or sink? A splashy mystery. Have you ever wondered why some things float effortlessly on water while others sink to the bottom? It's a splashy mystery that we're about to solve together. Get ready to dive into the world of science and uncover the secrets behind floating and sinking. It's going to be a fun and exciting adventure. We see things float or sink every day. A giant ship made of heavy metal floats on the ocean, but a tiny pebble falls right through the water. How can that be? Let's put on our thinking caps and figure it out together. Before we dive into the science, let's have some fun making predictions. Imagine you have a big bucket of water and a few objects: a toy boat, a fluffy sponge, a juicy apple, a shiny coin, a hard rock, and a colorful balloon filled with air. What do you think will happen when we put each of these objects in the water? Will they float gracefully on top like a happy duck, or will they sink to the bottom like a sad stone? Take a moment to think about each object and make your predictions. Now, let's unlock the first secret behind floating and sinking: density. Density is how tightly packed together the tiny particles inside an object are. Imagine a box filled with marshmallows and another box filled with marbles. The box of marbles is denser because the marbles are packed tightly together. The box of marshmallows is less dense because the marshmallows have lots of air between them. Just like the marshmallows and marbles, objects with less density tend to float, while denser objects tend to sink. Buoyancy. The water's upward push. The second secret to floating and sinking is buoyancy. Buoyancy is the upward push that water exerts on objects. It's like an invisible hand pushing things upward in the water. When an object is placed in water, the water pushes up on it. If the object is denser than water, the water's upward push isn't enough to overcome the object's weight, and it sinks. But if the object is less dense than water, the water's upward push is stronger, and it floats. Floating fun. Comparing objects and their abilities. Let's think back to the objects we talked about earlier. We explored various items and their unique properties, but now let's dive deeper into why some objects float while others sink. This fascinating phenomenon is all about density and buoyancy, two key concepts in physics that explain how objects interact with water. The toy boat floats because it's made of materials that are less dense than water, and it has a special shape that helps it displace water and increase buoyancy. The boat's hull is designed to push water aside, creating an upward force that keeps it afloat. This is why even large ships, which are much heavier than toy boats, can float on the ocean. A sponge floats because it's filled with air, making it less dense than water. The trapped air acts like tiny life jackets, showing how an object's structure affects its ability to float. The juicy apple, depending on its size and type, might float or sink. Apples have a natural buoyancy due to the air pockets within their flesh. However, not all apples are created equal. Some varieties are denser than others, which can affect whether they float or sink when placed in water. If the apple is big and has a lot of air pockets, it might float. The larger the apple and the more air it contains, the more likely it is to stay on the surface. The shiny coin, made of dense metal, will sink because it's much denser than water. Metals like copper and nickel, which are commonly used in coins, have a high density. This means they have a lot of mass packed into a small volume, making them heavier than water and causing them to sink quickly. The hard rock, also very dense, will sink to the bottom. Rocks are typically composed of minerals that are much denser than water. When you drop a rock into a tank, it displaces a small amount of water but doesn't generate enough buoyant force to counteract its weight, so it sinks. And finally, the colorful balloon filled with air will float effortlessly because air is much less dense than water. Balloons are filled with gases like air or helium, which are significantly lighter than water. This makes them buoyant and able to float on the surface or even rise above it. This simple experiment with everyday objects helps us understand the principles of density and buoyancy in a fun and engaging way. Recap. Congratulations, young scientists. You've done an amazing job exploring the fascinating world of floating and sinking. Today, we've embarked on an exciting journey to uncover the science behind floating and sinking. We started by looking at different objects and predicting whether they would float or sink when placed in water. This hands-on approach helped us understand the basic principles of buoyancy and density. We've learned that density, how tightly packed the particles inside an object are, plays a crucial role. For instance, a solid metal ball is denser than water, which is why it sinks. On the other hand, a piece of wood, which is less dense, floats effortlessly on the water's surface. Objects less dense than water tend to float, while denser objects sink. This principle is not just limited to small objects, it applies to large objects too, like ships and boats. Despite their massive size, they float because they are designed to displace a large amount of water, making them less dense overall. We also discovered buoyancy, the upward push of water that can make objects float. This force is what keeps boats afloat and allows swimmers to stay on the water's surface. The concept of buoyancy is essential in many fields, including engineering and marine biology. Understanding density and buoyancy helps explain why some things float while others sink. This knowledge is useful in everyday life, from choosing building materials to enjoying water sports. Science is a never-ending journey. At home, in class, or outdoors, there's always something to discover. Stay curious, ask questions, and keep exploring. Our amazing world is waiting. Thank you for watching. Stay tuned for our next video. See you next time.